completing the square. Completing the square is better than quadratic formula, but most students don't like it. I'm going to show you completing the square for the first one, okay?
Okay.
So the first thing you do is you actually move the 78 over to the other side of the equation.
And
And
then
you're going
you
to,
put a plus blank right there, right?
yeah, I put a box there to figure out what goes in the box. There are formulas. You're going to see me do it maybe slightly differently than you see in class. You divide this by 2. That goes down here in parentheses.
And then I believe you
And
square.
exactly. Okay. Now, to be fair, you do it the same to both sides. So plus 4 plus 4. So on the right, you get 82. The reason this is better than quadratic formula is from here, you can simply take the square root of both sides. You don't have to deal with the b squared minus 4ac plus or minus business. You just square root it. Square
Yeah.
root of both sides, plus or minus though. N
Hmm.
plus 2 equals plus or minus square root of 82. Do you remember how to reduce the square root of 82?
Yeah. Couldn't you do 2 and 41? Actually, no. I would
Yep,
do.
2 and 4. You always start with the smallest prime number, which is 2. In this case, you get another prime number, which is 41. That means you're done. There's no pairs, so there's nothing to do. So this is as far as it can go. You just leave it as is.
All right.
And then you subtract 2 from both sides. It's better to put that in front. So it becomes n equals -2 plus or minus the square root of 82.
Okay. And then would that be the final answer?
That is the final answer. Now, some instructors want you to present it, a certain way. Um,
Yeah.
this is
Today,
this is typically okay. Good.
yeah, today in class, she did say that on the test there will be different sections. Like partially, she wants us to solve by factoring on a few equations, solve by
Right.
like quadratic form. Yeah. So.
Okay. So if you've got the sheet in front of you, this is where I would jump in and say, okay, let me, pick one that's another completing the square. Do you have another problem you want us to look at?
Yeah. Let me
Or I
pick one.
can I can make one up for completing the square.
All right. I actually have one. It's n squared plus 16n plus 22 equals 0.
Okay, very good. All right. So just like the last problem, you move the 22 over to the other side of the equation.
Yeah.
And you'll see me do this over and over again. It becomes more important as the problems get more sophisticated, but the algorithm here, the recipe is you divide by 2. Now, do you remember why it's plus in here?
Hold on. I I was looking at my paper. I missed the last step that you did.
That's okay. So I'll just answer the question. It's not 16, it's positive 16. Like this operator goes with it. So when you divide by 2, that's why it's positive 8. Like if this were minus 16, it would be -8 here. We haven't seen one yet, but
Oh
that's
yeah, yeah.
okay. And
And then
then
and then after you square it, it's gonna be positive anyways, right?
in this problem, it is. Sometimes it can switch signs in different variations of problems.
All
Okay.
right.
So on the right-hand side here, 42. And then go ahead and try solving it from here, please.
All right. So I would put the square root over that n plus 8
Okay,
square,
very good.
and then equals the square root of 42. And then I would do 6 and 7 or 2 and 21.
So you start with 2 because
Okay.
2 is the smallest prime number, then 3, then 5, then 7. You shouldn't have to go much past that. And you're right, 2 and 21. 2 does not go into 21, so you try 3. 3 does, 7, but your leaves, your prime
There's no pair.
factorization, there's no pairs. So you have to unfortunately go back to what you had to start with.
So
Sometimes that happens.
that's considered simplified, right?
Yeah, there's nothing more you can do here, but you can move the 8 over, subtract 8 from both sides. It's always better to put it in front. That's kind of the preferred way of presenting your answer.
Okay. Yeah.
What I was referring to is some instructors are really diligent about, they're like, you gotta separate it. You gotta write it like this. Like, it doesn't matter to me because I'm not grading your paper. Do what your instructor wants. If they want them split apart, split them apart.
Yeah. I think when she wants like two answers, which is they're pretty much always going to be the same answer. You just swap out the negative and positive.
That's right. They're actually called conjugate pairs, which you'll maybe see or have seen. All right,
Okay.
very good. Doing great. So the completing square does get more difficult. So maybe look for a more difficult completing the square
All right.
problem.
I'm not sure if this one's completing the square. Actually, I believe it's not, but this one does look a little bit difficult.
Okay.
So it's 5 and then open parenthesis x minus 2, close parentheses, and then squared plus 1 equals 26.
Like this.
Yeah.
Okay. So here's what it sounds like. And I don't know if there's any way to get a picture of what you're sending over to me, it would be helpful. I'll just keep saying that. This is the square root property or the square root method.
Yeah.
And identification is really important. How many variables do you see here?
1.
One. Now, notice in the previous problem, you had an n squared and n, you had two variables. But after we completed the square, how many variables did you have?
1.
And what did we use when you had one variable?
Square root.
Square root. So your identification of when to use this is when you only see one variable.
Okay.
Okay. So this is really like a solving problem where the analogous problem is this. Let me just write the analogous problem. Let's say it was 5x plus 1 equals 26. What would you do to solve this?
I would subtract 1
Okay.
from both
So you,
sides.
so you should subtract 1 from both sides.
Yeah, and then 5x equals 20 negative or 25.
Okay. And then what would you do to solve it on the right here?
Divide by 5 on both sides.
You divide by 5 in your problem. Now, you don't have to write what I'm putting on the right side of the screen. I just want you to see that that's the style of problem that you're solving. X
Okay.
minus 2 squared equals 5.
And then you put the square root over both.
Yes. So give me your final answer, please.
Just give me 1 second, please. I'm gonna write it
Yep.
out.
Yep. Take your time. Sorry, I didn't mean to rush you. Just that's my cue for you to work on the problem, and
All right. Yeah, you're all
I
good.
I can't obviously see what you're writing. So
Yeah. I know this was a little bit inconvenient. Next time
no, no,
if I do in a meeting with you tomorrow, I'll definitely send you pictures of a bunch of things before.
yeah, no. I just wanted you to see if you like the format, and hopefully I can help you in a way that's positive and
All right. And then I got this is not my final answer. I'm not actually sure what to do after this step, but I got x minus 2 equals the square root of 5.
Okay, so big problem with what you just said. If you remember all the previous problems, it's plus or minus, plus or minus.
Oh,
Whenever
yeah.
you take a square root, you have to say to yourself, plus or minus, because there's two solutions.
Yeah.
Like we don't know what the square root of 5 is as a nice decimal. It's not irrational, but it is a number. It's square root of
Yeah.
5. That's plus or minus.
Okay. And then would you add 2 to
Yes.
both?
And then
You
better
put
to
it in
put it.
front of
Yeah. These are not
Okay.
like terms. You can't combine them. They're just terms.
So that would be the final. Yeah, that is what I thought was the final answer. I just wasn't sure if you put it before or after the plus or minus.
Okay. So that was not completing the square. That was a square root method
Yeah,
problem.
in the top right corner, I do have it written out. It says square root. So I must have went over that today, but I just didn't really remember. All right, and then I do have another one next to it that.
Sure. Yeah.
All right, so it will be 8a squared plus 3a plus 8 equals 0.
Like this.
Yeah.
Okay. Fantastic. So like, here's your progression. Your progression is the following. Um, is there a GCF? Okay, this is like overarching progression. The answer to this problem is no. Is it like a difference of squares? The answer is no. Is it a perfect square trinomial? Again, no. Is it an a equals 1? No. Is it an a not equal to 1? And that's what this one is. When I say a not equal to 1, and I'll explain this more another time, that's this leading coefficient. And that leads you to possible what's called grouping. Okay.
Yeah.
You try all this stuff first. Like you try all of these are way easier, way better than completing the square and quadratic formula. Okay. Now, to use completing the square, you generally want the middle term to be even, generally. Okay. Is
Yeah.
3 even? No,
No.
no. So that's bad. You've also got a leading coefficient here that does not go into 3, which is also bad. So to do completing the square, you're going to deal with fractions, which I could show you if you'd like. This one's leaning heavily towards quadratic formula. Okay. But like, think of quadratic formula as your last resort. It's like, you don't want to do that unless you have to do it.
Yeah.
Even though it always works, it's the most difficult one. Okay.
Mm-hmm.
So if you recall, when you use quadratic formula, you have to identify A, B, and C. Do you remember what those refer to?
Yeah, the A would be 8, B would be
Good.
3, and then C would be 8.
Okay. And if this was like -3, B would become -3. And if this were -8, it would be -8, hopefully.
Yeah.
You remember that? Okay. Do you remember the quadratic formula?
Uh, uh, isn't it like super difficult? I believe it's like
Yeah, I'll
negative
write it
B
out
plus,
for you.
and then
Yeah.
there's a 4 in there somewhere. Yeah, right there.
So what are you going to do to remember this before the test?
Study it.
Do you get a note sheet or a reference card or anything?
No, we do not.
Okay. So you have to memorize this. And you know yourself, you know what you need to
Actually,
do.
actually, to be honest, yeah, she normally, like, for all of our tests, actually, I'm pretty much guaranteed she will put the formulas up on the
Oh,
board.
good. That's good. That's good. Okay. So here's a little wrinkle that I really think is important when you're dealing with quadratic formula. You want to treat the letters like they're in parentheses.
Yeah.
Okay. And that it becomes more important when the A, B, and C are negative. For the positives, it really doesn't matter. The other thing that happens here is most of the mistakes are made in what's called the discriminant, okay, and the b squared minus 4ac. So I'd like
Yeah.
for us to just work that part out first. So it's parentheses 3 squared minus 4 times 8 squared times 8.
Yeah.
Are you guys allowed to use a calculator? Sorry, not
Yeah.
able.
Yeah.
Okay, so could you calculate this for me, please?
Yeah. Just give me 1 second, please. I'm gonna have to go grab. Actually, I have a calculator. Never mind. Just give me one moment, please.
Sure. I'm going to drop a calculator that I like in the chat. It's the Desmos Scientific. It's very helpful. You may find you like it.
Okay. I do. Were you wanting me to use that one? I did get my.
Oh no, no, you can use whatever you want. I just want you to be able to calculate this.
Okay. It's just gonna take me a second to plug this in.
Sure.
So 3. Do you want me to put the 3 and the 8 in parentheses?
It depends. I like to show substitution in parentheses. It also implies the multiplication.
Okay.
You it's not really a big deal how you do it. You just have to know that you're multiplying. Like you don't have to have parentheses, but I like to show it that way just for clarity.
Yeah, I actually like to do that too instead of drawing like the actual multiplication symbol. All right. I got negative 247. Oh, was I supposed to divide it by 2?
Not yet. No. So that's the part under the square root. So it's the square root of this, which you just told me is the square root of minus 247.
So should
And
I?
then, nope, just hang on. Just
Okay.
bear with me here. Minus 3, because b is 3 over 2 times 8, like this. Now, did you guys talk in class about how to deal with negative square roots?
Yeah, actually, I do remember something under the negative square root comes out to be no solution.
Yes, that's what I'm looking for because it depends on where you're at in the course. Are you in your regular algebra 1 or algebra 2?
I'm an algebra 1.
Okay, so you have not learned how to deal with this yet, which is fine. So this
Yeah.
has no solution.
Okay. So
And
the
and
answer.
there's no, yeah, that's it. Now, if you come back to me tomorrow and say, hey, we actually do know how to deal with this, then we can talk about how to do it.
Okay. Yeah, but I'm like pretty much 99% sure she just wants to write
Yes.
those.
Yes. So quadratic formula, the main thing that students mess up on is the discriminant. So if you got another quadratic formula problem, it'd be good for us to work on now.
All right. All right. I think this one is one.
Okay.
4x squared plus x minus 14 equals 0.
Okay. let me check something here real quick to answer your question about whether it is. This one is actually a factoring problem.
Okay.
So this is that when earlier I wrote A not equal to 1 grouping.
Yeah, I think like on the test, I just like one of my big problems at the moment would just be like I don't really know how to identify when.
I understand. So you would try this first. Now, because the leading coefficient is not a 1, it's this type here where, and I hope you saw this in class, you take the 4 and you multiply it by the minus 14. Did you
Yeah.
guys? And you get minus 56. And now you're looking for two numbers that multiply to minus 56, but add to positive 1.
Oh, yes, I have done that. So
What would those numbers be?
7 and 6.
7 and 6 is 42.
Oh shoot. Never mind, not 7 and 6.
You're
8 and
close.
7.
All right. Now, is it negative 7 and 8 or 7 and negative 8? Which of those adds to positive 1?
7 and 8. Negative 7 and 8.
Okay. Now, this next part's important. What you're doing is you're breaking apart 1x into minus 7x plus 8x or 8x minus 7x. Like all I did was switch the order. And you have to decide which pairs better with 4x squared. Does minus 7x pair better with this, or does the 8x pair better with this?
8x.
Yes. Okay. I'm going to get rid of this up here. From
All right.
here, you use what's called grouping. So you find the GCF between the first two terms.
So that would be 2. Or no, 4.
4, and then what about the variable? GCF can be more than a number. It can be a number and a variable.
Oh, and you could also take out an x as well.
That's right. That's right. So I just need to rewrite this here because you're gonna want to see this. Okay, so when you
Wait,
take out a 4x, you're
and then you
dividing each of these by 4x. What goes in parentheses here?
um 4x. You would have an x plus, or no,
Yep.
yeah, x plus 2.
Good. Now you immediately write what's in parentheses over here to the right
Okay.
with a little space, and you figure out what goes in the space such that when you multiply in, you get back to the previous line. Basically, look at the constant. How do you go from 2 to minus 14? What would you multiply by?
Negative 7.
There you go. Now, it's called factor by grouping, but it's really double factoring because you have to factor out again. You have to factor out an x plus 2 from both of these. Both of these terms have an x plus 2 in them,
Yeah.
and that can come out. So it ends up being x plus 2
All right.
times 4x minus 7.
Okay. So x plus 2 and then in parentheses. Wait, how did you get the 4x minus 7? I'm sorry.
So
I
you're like one of the things that they think is it's 4x times x plus 2 is this whole thing is a term,
yeah.
and this whole thing over here is a term. So they have a common x plus 2 in them, so you can factor that out, and you organize what's together in the next step.
Oh, okay. Yeah. Now I totally understand. It's the 2 things on the outside of the parentheses right there.
Exactly. Yes.
Yeah.
Okay. Now you have to set each of those equal to 0.
And then once you solve those are your 2 answers, correct?
Yes.
All
Can you
right.
tell me
So
those two answers?
yeah, x equals negative 2. And then the other one, I would add 7 to both sides.
Good.
And then divide by 4.
Good.
So 7/4.
You got it. Good job.
All right.
It would be
Yeah,
good to
so
do another problem like this, but you're welcome to pick.
I could see if there's one in the front. Hold on. So that was unfortunately I can't seem to find one similar.
Yeah, that's it's okay. Go ahead and just if you see another problem you'd like us to work on, we got about 5 minutes left before we're gonna stop for the try it out lesson.
All right, yeah, no worries. Yeah, this one does look a little bit easier, but I think this is the factoring one as well. So I think it's 4x squared plus 44x plus 120 equals 0. So I
Very
know
first step.
you
Yeah,
could factor a
that's it.
4 out of all that. Yeah.
Yes, so do that. Tell me what goes in parentheses.
Um. Oh, I forgot that you have to put the 4 on the outside.
Yes, because like even though you're dividing, I guess they call this divide and slide. I always write it on the left here first because I don't want to forget it because like you just mentioned, it's so easy to
Yeah.
not have it there.
All right, so it would be x squared plus 11x
Good.
plus 120 divided by 4. That is 30.
30. All right, so now your attention moves to what's inside parentheses. Like you keep factoring until you're done. And a lot of students will ask, well, how do I know when I'm done? You do enough problems where you see, okay, if it's either reduced or can't be. This one can be. You're looking for two numbers that multiply to 30 but add the positive 11.
Yeah. Okay, so not 3 and 10.
So
Two.
the list is important, and you'll see that the faster you can make this list, the faster you can determine which
Yeah,
pairs.
that's what I always do too, but I don't have much space on this paper. But anyways, first off, couldn't you put an X on both sides of the double bubble? Like, or
Yeah, but give me the numbers. Tell me which one works here.
all right, 5 and 6.
Right, so it's x plus 5, x plus 6. The order does not matter. You prefer.
Also, yeah, also if there's no negatives in the equation, then you know there's not going to be any in the bottom, correct?
There's three cases, maybe four. If these are both plus, your answers are both plus. But as soon as you switch to a minus and a plus, they're both negative.
Yeah. Yeah,
And then
yeah.
the two others, which are really the same, if you have minus minus or plus minus, you end up getting one negative and one positive.
Yeah.
What's the final answer though? Because we're setting this equal to 0. What's the last step here?
Um setting I'm not sure.
You set the x
Oh.
terms equal to 0.
Oh yeah, yeah, yeah. Okay, yeah.
Like
And then
like you're not done. 4 is not a term. It does not have an x in it. It's just a coefficient.
so is the 4 completely eliminated from the problem now?
It doesn't well, you can't remove it because it changes the shape of the graph, but it doesn't change the intercepts. So you have to leave it, but it's not part of solving this because what you're essentially doing here is you're saying if one of them is 0, I get 0.
Mm-hmm.
Like 4 times 0, 0, 4 times that 0, 0, like whatever, it's there, no big deal. You have to set the x terms equal to 0.
Okay. Okay, so then your first answer would be x equals -5 and then x equals -6.
Yes.
All right. Yeah, to be honest, I don't think these are too overly difficult. It's just like, for me, like, I don't know if this is for other people in math, but once something clicks, it clicks. Like, and for some reason, this concept is just like not really clicking for me.
Yeah, let me go ahead and just stop the recording right here.